Today we'll be doing the integral from 0 to 1 of x dx. And to start off, we could recognize that the integral from a to b of f of x dx is the limit as n approaches infinity of the sum from I to n of f of x sub I times delta x. And delta x is defined to be b minus a over n, and f of x sub I is defined to be a plus I delta x. And in this case, our interval is from 0 to 1. And this is our a and this is our b. So delta x is 1 minus 0 over n, which is 1 over n. And our f of x sub I is a plus I delta x, which is 0 plus I delta x. But we said delta x was 1 over n. So this is I over n. So the integral from 0 to 1 of x dx is the limit as n approaches infinity of the sum from I to n of our f of x sub I, which is I over n, times delta x, which is 1 over n. This is equal to the limit as n approaches infinity of the sum from I to n of I over n squared. And from here we could put the 1 over n squared in front of the summation operator. So you have the limit as n approaches infinity of 1 over n squared times the sum from I to n of just I. And we have to recall that the sum from I to n of I is n times n plus 1 over 2. So we have the limit as n approaches infinity of 1 over n squared, n times n plus 1 over 2. We could factor out the 1/2 the limit as n approaches infinity of n times n plus 1 over n squared. And one of the n squares cancel at the bottom, so we have 1/2 the limit as n approaches infinity of n plus 1 over n. And we could break apart that fraction, so we have 1/2 times the limit as n approaches infinity of n over n plus 1 over n. So 1/2 times the limit as n approaches infinity of 1 plus 1 over n. And as n approaches infinity for 1 over n, that it's going to go to 0. So we have 1/2 times 1, which is 1/2. So therefore, the integral from 0 to 1 of x dx is 1/2. And that is the final result. Thank you for watching.